All right, so hold up, just so we understand what's happening. We are going to start by first reviewing 511, 512's homeworks. If you haven't done them, it's okay. They're not due till next week, but you're missing out on the benefit of being able to check did I do it right or not. Now, this is going to be recorded, so you can always go back and check the answers. Obviously, it's not about the answer being on your paper. Otherwise, me showing you the answers wouldn't make sense. It's about you understanding the process, because let's think about mastery, guys. Right? If we have mastered a skill, we should be able to do it, like, pretty consistently. So, check your answers. You got, like, not a long time. Aiden?
Oh, never mind. Wait, did it ask on 510B? Did it ask that you know how much is needed to fill it up?
How many gallons are in the tank now? How many more are needed to fill it? So, if you know how many are in it now, then it's, you should be able to figure out how many are needed. So 50% would be 40 gallons, and then another 0.5% would be another 4 more gallons. So the 55% full, that's how we get our 44 gallons. And of course, to make it, now, here's the thing. You wouldn't actually put 80 gallons in an 80-gallon fish tank. That would be fill it, but that'd be real dangerous. You normally don't fill it all the way up. But if we're talking just the math, yeah, it'd be 36. All right, check 11. They have fraction form, decimal form on a few of those. Sorry, they have fraction over, like. So if you look at question 11, it's what is the resulting, and or what is the giant one that we would use. So how do I go from 20 to 110? So, like, there's the problems, right? The giant ones that we're filling in, or the answer out here, or this value, or, yeah. So that's why there's 2 different answers. Sky?
Okay, so we are allowed to, like, since, like, because I got decimals, so we're allowed to do, like...
You can put decimals in the fraction. It just becomes a complex fraction. So these... Going back on the TV. These fractions right here are complex fractions.
For C and D, yeah, okay. So then I'm fine.
So you could have also said 5.5, like mixed number. And you could have also said 11 halves. Improper. But any fraction that is not just a number over a number, like if it involves decimals or other fractions, is a complex fraction. Okay. Check. So I'm not as particular on 12. If you looked up the proportions web, it's trying to get you to be able to see every different view of it. That our graph would be a straight line coming from the origin. Our equation would just be a number times the other variable. The number, the constant of proportionality, the thing that makes it proportional, is 11.34 because that's the unit rate. And then if we make a table, that would be how it would start. So be ready that would be a question and a mastery probably after we come back from break. And then there's 13. Questions? We can't play this game, so I'll do it right now. But if we're checking homework, like, you got to be with me or stop me right then. I talked about this for a minute. All right, and then in 512 last night's, which I know a lot of you probably don't have done quite yet, but that is fine. I'm looking at, so go ahead and check your answers and then just keep kind of listening to me. I'm looking at posting answers coming second semester, like after winter break. I'm thinking about posting answers, not the whole solution process, but answers on Schoology. That then I would expect that you go and check your homework once it's done. I mean, guys, Homework Help offers up a lot of the answers, or like all the steps to get almost to the answer. So I want you guys to be able to verify, did I do it right or not? And if not, you should ask a question about it. Right? So what I'm looking at, what we're kind of practicing right now, is when you get done with the homework, you should check it. Back in my day, we had the answers in the back of the book. We had like the odd answers. And we would just, you know, every time you did an odd problem, you'd check that answer then. Yeah.
For B in 518, I got 15/5.
Well, it says to simplify it.
Oh, yeah, you have to reduce. So if it says simplify, you got to reduce your fraction. So in 18, simplified ratio. So 15/5 isn't wrong, but they ask for the simplified ratio. So what you're saying is 3 parts yellow to 1 part red. Even though we had 15/5, when you simplify that out, it's 3 to 1.
I put 1 to 3. Is that okay?
No, because that would be red to yellow. Since it asks you specifically yellow to red, you want to flip around that ratio.
Okay.
So 3 to 1.
It's 3 to 1. Yep, 3 to 1. 15/5 is right. It's just not simplified, right? Questions 19, 20, 21? If you haven't done this yet, it's okay. You can even like just jot down the answer. I mean, they're going to be in the video, right? Red frame around this. I'm recording, so you can go check answers in the video if you're not doing it right now. But these homeworks will be due next week. And guys, I really want this to enforce. It's not about the answer. It's about the process. Okay? Not about the answer. It's about the process. That was likely my dermatologist, but I will talk to them later. All right. Ready to go? Let's take a shift to the side. So we've been doing percent work, and we will continue to do percent work. But what I love about CPM is how it doesn't just like pound in the stubborn nail. So who's ever built anything? Yeah. So nice. So sometimes you get a nail that doesn't want to go in. You hit a knot or something else. And sometimes in our learning, that sort of happens. Like we start to try to learn something, and it's like, oh my gosh, this is like walking through molasses. Like it's tough. I don't want to keep doing this. So we did 2 lessons with percent work. Right, we're taking a shift to the side. So it's gonna feel like, wait, is this related to what we did yesterday? Kind of, yes, but it's not the same stuff continuing. Cool. So if I have a deck of cards, my smartboard appears to be goofed. Goofed. Try this. It is 12/12 today. So when we play a game, like say you go to the fair, or you know, say you did Phoenix Fair and somebody ran a game there, or like if somebody describes a game as fair, what does that mean? Versus like if somebody says, well, that game's rigged, right? That game's unfair. Maybe?
Nobody has an advantage.
Nobody has.
Equal opportunity.
No one has any advantage or disadvantage versus everybody else. Like it's all the same. I like it.
Like everybody has the equal opportunity to like get the same thing,
And-
and it just kind of depends on like.
Yeah. So everyone has an equal opportunity to get the same, like to win or to lose, right? If I have a 1/5 chance of losing, you should have a 1/5 chance of losing, and you should have a 1/5 chance of losing. So a fair game means that, like, you know, things are kind of spread out evenly. So certain things are fair, other things aren't. So what if I propose to you a game where we're going to use a deck of cards? And I propose to you, and I want you guys to discuss these things really quick because I'm making this up as I go. Or not like this is not in the textbook. Okay, not like I'm making it up as I go. But talk with your team really quick, and then I'm going to use cards to get an answer from somebody. If I make a game of, we're going to play against each other, right? Students versus teacher. I win if it's a red card. You win if it's a black card. Is that fair? Talk with each other real quick. And why? This is coming to you, Brett. Make sure you talk with your team.
What if it's more champion?
Well, he said that they shuffle it.
All right, Greta, what do you think? Is that game fair? No, why? You got to support it. So I'm going to pick a card out of a deck. Maybe I didn't explain this right. I'm going to pick one card. We're playing, it's just me versus you. If the card's red, I win. If it's black, you guys win. So does how many of you there are change what's going to happen? No. Ava, what do you think? So you're in the same group, so this isn't like a great next question. We're not using the book. I'm talking about a deck of cards, but I'm doing a little bit of teaching on my own.
Okay, so I think because we didn't understand what you were saying, so I think it is fair because there's the same amount of people and you're giving like the same amount of cards.
Yeah. I didn't explain it very well, but yeah, that would be fair, right? In a deck of cards, they're split red and black, right? So in a deck of cards, they're split red and black. Equal cards of red and black. You have an equal chance of winning, as do I. So I'm going to change the rules a little bit. If the card, because my pledge name when I joined a fraternity was numbers, if the card has a number on it, I win. If it has anything else on it, you win.
Whoa.
Is that game fair?
No.
I was going to have you talk as a team, but okay, Casey,
Oh joy.
do you want to talk about why that wouldn't be fair?
Sure. Because there's more cards with numbers than there are smaller numbers.
In a deck of cards, there are 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 9 cards with numbers, right? There's no 1. And if we think about the other cards, Jack, Queen, King, Ace. Ooh, okay. We don't normally talk about jokers.
Oh,
So let's understand this right now. A standard deck of cards, we don't talk about jokers. Okay, if they say like in a special little with jokers, with 2 jokers, with 4 jokers, that changes things. But when we talk about cards, we're not talking about jokers. Okay, in the real world, when you walk into the casino, they're not playing with jokers. Yeah.
Is this in addition to the old rules?
What do you mean? Oh no, we're not piggybacking on that. That would be interesting. So I want you guys to, as a team, think about these things right now and see if you can figure out, and then we're going to test it. What is the probability of black in a deck of cards? And when we talk about probability, what did we say? Because we did this a while back. What did we say about probability always, Jalen? P parentheses. So go ahead and write this in your notes.
probability.
And this is number 23. So then number 1, question 23. And what do we know probability is going to be between? I had this poster up here for a while, not the food poster, but I had a poster up here with Mr. Hudson becomes a famous YouTuber. I go home after they know. What do we know about probability? It goes from something up to something, always.
1 to 100?
If we're talking percents, yeah. We need to remind ourselves about probability. So give yourself a little bit of space to answer these questions, but then please write probability. And we're going to draw the same thing we were drawing yesterday. Probability always goes somewhere between 0 and 1. What does a probability of 0 mean? Impossible, right? Cannot happen. What's a probability of 1 mean? Ooh, not just very likely. It's certain. So above your 0 or below, if you put your 0 above, this is impossible. And this over here we call certain. C-E-R-T-A-I-N. So with your team, figure out what's the probability of black, what's the probability of clubs, and this is why we're working in teams. I know some of you know more about cards than others. And then think about C. I'm going to leave this up here so you can read. I won't read it for you, but talk a couple minutes about those 3 questions. Okay, we got to decide how much money we need.
Yeah. I'm going to go to PTSA today. There's no more forms in the office for fund requests. So I can't even fill out a form. But I was going to request the money, and then they say yes to fill out the form. because it's going to be a club, not just for phys ed. Like, I don't know. I think you might support it.
But yeah.
What do you have in your budget?
I vote.
Oh, so like same thing, right? For calculators and stuff? You can have like $200 or something.
Oh,
Yeah,
no, but
Yeah, it goes pretty fast.
I do have to make that happen.
Two of them are children.
But I could probably spare them.
This year, math is now switching to us having to buy all our own stuff. Like the first year was like, okay, here's all the whatever. But now it's whatever you want to use. That's why it's
Oh, for the CPF.
yeah, any of the resources.
Yeah.
It hasn't let me know, but it should be. When's the last time you like? I was just updating stuff this morning. So yeah.
All right, I got more papers to hand back, but let's chat about this real quick. If I clear this ink out of here. Our probability of black, which I had written there, but I'm just going to write real quick here. Eva, that was perfect. We just talked into your card was on top. Joey, what did you guys get for your probability of black? What?
That's what you guys said. 26
I was about to say 26. That's not between 0 and 1. 26 over 52. Which can reduce, we always like to reduce our fractions down to what? 1/2, because half our cards are black. Now clubs, we have to know what clubs are. Club is a type of, what do we call those divisions of the deck? Suits. So club is a type of suit. So, you want to go ahead and tell us what the probability of clubs is? Thank you, Brody. It's 13/50 seconds. And what does that reduce to? 1/4. Now, if you drew a card from the deck and replaced it, and you repeated this process 100 times, how many times would we expect to get a face card? Now, this is where it gets touchy. Some people think aces are face cards and other people don't. I don't really have a definitive answer for that, but here they're telling us King, Queen, Jack, right? They do not talk about aces. So, did we get through this problem with our group? So, here's my advice. First, determine the probability of face, like a face card, and then use that to say how many out of 100 would we expect. I'll give you another minute or two to work through that. Yeah. Oh, I figured out. I think those are alternate discs. When I read through it first, I was like, alternate. Like, what is alternate called? And then I was like, oh, alternate. We can. So they're going to put them all in the same box.
Whoa!
Where's some of this? Just because we're in. Or can you really see? Like, it's kind of dark in here. Sure?
It's always dark.
Let me check.
So then it would be.
I don't want to mess up your sunglasses. I thought it would look cool.
Okay, so then all we have to do is
What? So what? Me?
I'm a lot of
Okay. So you're confused?
I'm
confused. If this isn't changed in math, you see, those should have been attached. Maybe I realized that. Maybe I figured it out.
All right, I got more to hand back, but we got more to do. What is the probability, who am I talking to? Aiden, of a face card? So just in general, what's the probability of a face card?
I still don't understand what a face card is.
So a king, a queen, or a jack. A card that has a face literally printed on it. That's why aces aren't. So let's back this up. In a suit, and my card players might need help, in a suit, how many cards are there? That's in the whole deck, in one suit.
8. 4.
Brody, can you help us out? Do you know? Not face, just how many are in a suit? What? How many? 13. So hey guys, in one suit, there are 13 cards. So if I think of out of 13, how many of those are faces? 3. King, queen, jack.
Yep.
So we could have that there are 12 total face cards in the deck, but this is a reduced form, but actually this is going to be easier to work with. So I'm going to put 1250 seconds down here.
I don't like that term.
Now, why did I say 52 is going to be easier to work with?
Because
Sky?
it's easier to get to 100 because you can like an estimate would be.
It's really close to 50. Yeah, exactly what Sky said. It's easy to get to 100. So, Aiden, coming back to you so you can help me a bit. How could I approximately get to 100?
Oh, you can.
The approximate. If 52 is really close to 50, how do we get to 100? So if we start with times 2, right? So this is almost times 2.
Oh, I thought you meant,
So the top is
it's 23.07, so blah, blah,
yeah.
blah.
So if we did times 2, it'd be 24, but it's not quite times 2, so maybe 23.
I did it exactly.
Maybe 23. So let's test this.
Closest you can get without going over is 1.9.
So we said, so don't count this card. We said the probability of black is a half, right? The probability of clubs is a 4th. Then we said the probability of a face card is like 3 out of 13, kind of weird. But let's try this out. So shuffle up. Got a black club. Somebody keep track of this. So you could just write like B, C. Or you could say like 10 of clubs if you want. Ace of spades. The ace of spades.
Oh, you're
It's a song. I didn't make it a song. Can you be less judgmental? Like, I think your classmates might appreciate that too, and I'm just gonna straight like, come on, man. I'm trying to make class fun, and you're like, bringing it down.
You need a 3 and you win.
7 of diamonds. Because it's shuffling. When you put the card back in, you gotta shuffle.
You win over 21.
10 of spades. Good thing we're not playing blackjack. Another 10 of spades.
That's not normal.
What do you mean that's not normal?
That's too many 10s of spades.
What do you
You
mean
win
that's
way over 21.
That's like a lot.
So,
Wow.
let's talk about this for a second. What is the probability I draw that specific card, the 10 of spades? If I walk up to you and I'm like, hey, I want to play a game. If I draw the 10 of spades, I win. Anything else, you win. 1/52. Here's math you don't need to know how to do quite yet, but this is what Layla's talking about. I just had that happen twice in a row, right? The math behind that is actually 1/52 times 1/52, which is 1 over, somebody do 52 times 52 real quick. Nobody had, Labib has a calculator. Do you know it already?
2,704.
2,704. The odds of that happening is 1 out of 2,704. Now here's the funny thing. This deck is it's an algorithm. It's a computer program. It is randomizing and spitting out a random result. We just got a result that the odds of is 1 out of 2,704. Does this mean it's impossible? No. It's just really unlikely. Now, the way that casinos work they hedge the games, they know the probability, they are going to win more than they lose based off math. And guess what? No casino's ever shut down because the math didn't work.
Well, no, like, you don't usually get as much money. Like, scamming.
Yes, because the math supports that the odds are in the favor of the house winning. When you walk into a casino, the house, the casino, they win. If you lose, they get your money. So, chill with the side conversations. Let's explain something you may not know. A casino is a place where adults. Like, I'm talking and you're talking, and if you have something to say, I will wait. A casino is a place where adults go to gamble. Gambling is when you bet on an outcome, right? So we're teaching you probability, not so you can go lose your paycheck at the casino, because that's what's likely going to happen is you're going to lose money. We're teaching you probability to make choices in life based off that. If you've ever been riding with your parent and the light turns yellow, they have to decide, do I go or do I stop? It depends. Like, sometimes it's more dangerous to try to stop because I'm already too close to the intersect. Like, that's probability in the real world. So, casinos have a variety of games. Some of which you might have seen on TV or whatever, like slot machines and whatever. And those are computer programs, right? Those now are all computers. There's like barely any just mechanical slot machines, but there used to be just machines. Not a computer, but a machine that inside there was a lot of stuff happening and there was probability still functioned into it. But the machines now at the casino are set to have certain payouts every so often so that they're taking in more money than they're giving out. That's just a computer program. But when you walk over to the tables, I'm probably going to get a couple emails about this. When you walk over to the tables, there's card games, dice games, all these different games where your brain says, well, it's fair, right? It's a deck of cards. I know what's in a deck of cards. I know how many sides are on the dice. But all of these games have been analyzed by smart people, and the casino's point, like their perspective of the game, of who wins, who loses, the math says they're gonna win. So when you walk into the casino, you should be expecting to lose money. If you win, you got lucky, which means the odds weren't in your favor. I will never walk up to a table and say, I bet you $20 I can get a 10 of spades 2 times in a row. Because the probability is 1 out of 2,704. Unless you're trying to lose money. But I would walk up to a table and say, I bet you I get red. Because that's a 1/2 chance. That's actually the best bet that you can find in a casino is a 1/2 chance. And you barely find those. Even the roulette wheel, if you've ever seen a roulette wheel, doesn't just have red and black. It also has green spots. So it's not a 50-50 probability. You actually only have a 40, I forget if it's 48 or 49% chance of winning, but you have less than half, which means you have a bigger chance of losing. So guys, if at least one of you in this class learns from our unit of probability how to not go and lose a ton of money at the casino, I can sleep at night and be happy that I'm a teacher. Okay? If the only thing you get out of this lesson is don't expect to win, like that's okay. Scott.
Yesterday there was a show that I was watching, and they had like this whole thing and was gambling, and then my mom went on a big giant rant about how you should never do that, and yesterday she taught me like what you just taught me.
Yeah.
Because she got mad because she lost like, a lot of money once. So then she was like, it sounded very boss. That's what she sounded like?
Yeah.
Exactly like that. Well, it's okay.
Your mom's gonna go watch my video. Jalen, what's up?
Tonight at the parent forum, you're gonna hear from my mother. She's gonna ask you why subtraction's not real because I told her
Oh, I can go. I can.
Video. I know. I
This will be
that he
fun.
was like gonna give her a lecture about it.
Did you also tell her that division doesn't exist?
I told her that. She laughed.
Division's just multiplication. There is no division. There's no subtraction and there's no division. We made these things up.
We made everything
There's
up.
addition. No, there is addition when there's a herd of animals and more animals come and join them. That's addition. When the wolf comes and eats 3 of them, that's addition of a negative, right? The wolf added a loss of animals. This might be how I explained it to your mom. There's no division either. Like, you're multiplying by fractions. Layla?
My dad yelled at my homework and said, "Why did you change that?"
Why didn't you?
Yeah,
Oh.
my kids say that
Call
all
me.
the time.
Text me, call me. I got you.
My kids are like,
All right,
"Why did
we
you
gotta
change
refocus.
that?"
We gotta refocus. So, for what it's worth, we're ahead of schedule compared to last year. Not what I wanted to be for this year, but that's okay. I set lofty goals. We're ahead of schedule for compared to last year. When you have questions and when something's interesting to you, I'm okay to go off on a tangent and like go down a road and explain things and like educate you beyond the textbook. I'm happy to do that, but we gotta keep like some forward motion. So when we need to refocus, we gotta refocus. Okay? Like I'm okay to shift plans and everything else if we find something we're really interested in. And probability is super interesting. This is probably my favorite stuff to teach this year because there's so many games behind it. And guys, if you came to my house, you'd laugh at the amount of games we have. If I stack up the games that we have, it'd be taller than me. The amount of board games we have at my house, there's different shelves of them.
We have 7 games.
Yeah. So, is it a question? I can't take more comments because I'm running out of time. Okay, what's up?
So on this, so you're basically saying it's not fair. I mean, the probabilities, like, for the card deck, it's like, you're saying it's 1 out of 2,140.
That's the odds of us getting that 10 of spades twice in a row. It's really, really rare, but it's not impossible. It's just really rare.
Well, we got it.
I know. We got a really rare outcome. I mean, even a wrong clock or even a stopped clock is right twice a day. Like that's a joke about it's right. But like it can happen. Think about a deck of cards. If I put that card I just got back into the deck, it's there. I could get it again, but you'd have to shuffle and randomly. Like you have to get lucky.
Ooh, that's cool.
Natalie, then we got to move on.
Okay.
Sorry, I'll come back to you.
One day, can we do like roulette, but like with fake money?
Maybe I get really nervous about like I've had that thought of like let's turn my classroom into a casino and that, but I get nervous about that like angry email that's gonna come from some parent that's like I don't want my kids doing that. So maybe,
Maybe you should send out like a permission slip.
yeah. Maybe when we come back in January, I'll think about it. But okay, we said, hey, what did we say the probability of black was?
Oh, 1/2.
1/2. How many black cards did we get out of our?
We got 3.
We got 3 out of 4.
Well, we actually got 4 because.
Yeah, I didn't put that last one on because I wanted the math easy. Shh, come back. When we gotta bring it back, we gotta bring it back. How many? What was the other probability we did?
Spades.
Probability of spades. What was
Club,
it?
not spades.
Probability of clubs. What was our probability? 1/4, right? Did I get that probability?
Yeah.
Yes. So I need your eyes. The difference in probability is between theoretical and experimental. We'll write these down at some point. I know it's fun. We'll write these down at some point. When you actually do it, when you shuffle the deck and draw cards.
Oh my god! Whoa!
So, when you, it could
Oh
be
my
a glitch
gosh.
in the program, or it could have actually been written like that. I'm not sure. I didn't write the program and haven't really analyzed it.
Do you want to know what the probability of that is?
1/52 to the 3rd power, I'm sure. But
It's 1/140,608.
so, that, what Ethan just read, is the theoretical probability when we just do the math. But what we just found out by our experiment, we got it like 3 out of 8. Right? So, eyes, so I know you're listening. Experimental probability doesn't always come out how we expected. But that's fine. It was an experiment. Things happen differently when we run an experiment. Theoretical probability, and what we talk about more often, is the math. When we look at a deck of cards, how many of them are clubs? 1/4. How many of them are black? 1/2. That doesn't mean when you start drawing cards, half of them have to be black. It's not necessarily going to happen. Does that make sense? What actually happens doesn't always match the math. As we just saw, what actually happens doesn't always match the math. I got to click. I can't actually tap with my finger on there. So we got to do a couple problems fast, and I'm guessing this is actually going to modify my plan for the week. So the complement, and we want to write this down. The complement to the event is the other outcome. So a complement, the easy definition is the other outcomes or like slash the not what we wanted. So if I'm betting my money on clubs, what's the complement? The other seats, right? The not clubs, the spades, the diamonds, the hearts. If I'm betting my money on black, what's the complement? Red. If I pull out a die, right? How many sides are on a standard die? 6, unless you're a super nerd and you like walk around with a D20 in your pocket. What is my probability, which a D20 is a 20-sided die, what's my probability of a 1? 1 out of 6. What's the complement event? Like what things are the complement to 1? 2, 3, 4. Yeah, all the other options. Does that make sense? The complement's the other stuff. It's the not what I was looking for. So, moving on. Okay, I don't know what you did. You're not capturing or anything. So, if we talk about the probability of not getting a club, well, we said the probability of getting a club was 1/4. So, we talk about the probability of not a club. Yeah, it'd be 3/4. So if that casino game is pick a suit, and you have a 3/4 chance of losing. You got this written down, Natalie? You look cozy in your blanket, but I don't know if you're right. Hey, your sass doesn't help get it on the paper either. Oh, you're looking at the board with like a sassy 7th grade look. That is really fun.
She does have a really mean face.
That's not
No,
nice.
she always looks like she's mad at somebody.
All right, with your group, figure out what's the probability of not a face card. You should have written down what the probability of getting a face card is. What's the probability of not getting a face card? I think this is you. Correct me if I'm wrong, and then check that that's in math. Like not right now, but later.
Yeah, it is mine. Not face weird. Yeah, it is.
What was the probability of getting a face card?
12/52.
12 out of 52. So how many cards are not faces? 40. So our probability of not a face card is 40 over 52, which we could reduce. Questions on how we're figuring out these complements? We essentially can do a subtraction, right? If I know that there's 52 total, what's that? You're right. We can do addition of a negative. Lane. Lame. I need to scroll and my pen's over there. Lame. Look at 52. Read this situation. We got like 3 minutes left. We got enough time to debrief this. Read this. Sorry, 25. My brain switched. Yeah, I'm thinking decks of cards. What? Yeah, I wrote that there. I wrote that there, then you came and saw me. If that's still in math, you see me, but I think I wrote like that was old. I forgot to pass that paper to you. So the circle grade is the grade for the whole package. So those are like the easy assignments. And what's the everything else? So this is an interesting split for the game. Rob decides to play a card game with Travis. He told Travis if he picked a black card with a value of 9 or greater, 9, 10, Jack, Queen, King, Travis would win. Jacks, Queens, and Kings are considered to be greater than 9. Yeah, so that's just clarifying. There is 10. 10 is, of course, greater than 9. They're just clarifying where Jacks, Queens, and Kings sit in like the ranking, that they are higher. All right, so class is already switching, so we will pick up here and help figure out Rob's game tomorrow. Kevin, Aiden, Ethan, I still got papers for you guys.
I'd like to touch this chapter for pleasure. I'd like to check.
Make sure that that's not still in math. Because if so, I need to fix it. Okay, but make sure it's good in math. Okay, if it's not, let me know. You guys, sir. Thank you. So what do you think? We made a ton of money on the direct ride. I don't think it's out of line for us to ask.
Yeah, so, I mean, it would be nice.
What? The what? Oh yeah, please do. Thank you very much.